Hello! Welcome to Agnisys video. Today we will show you how easy it is to specify the hardware-software interface and generate usable code from it. We use a Zedboard for this purpose because it enables new users to quickly get started using the Vivado toolchain, and also because the Zedboard and the Zync FPGA on it is quite versatile and yet quite inexpensive. We will show how you can specify the hardware-software interface in IDesignSpec, generate RTL code, and use the generated code in Vivado. Next, we will use ISequenceSpec to specify a sequence of operations and run them on the board. We will show all this by way of a small project where we will write a sequence of bytes in the software and have it appear on the board LEDs. Hardware-software interface consists of addressable registers that are configured by the host bus. For example, the status control registers that are read written by the bus, interrupts in both directions, and a list of sequences that initialize and program and form a layer of API around the hardware. IDesignSpec is focused on the registers, interrupts, counters, FIFOs, timers, etc. And ISequenceSpec is focused on the sequence API around the hardware. This is the block diagram of what we will create. We start with IDesignSpec in Word or IDesWord. IDesWord is also available in Text, Excel, or OpenOffice. We add a register, specify the access for the registers appropriately. Now, generate the RTL and a tickle script that helps the integration process. Now open the Xilinx Vivado IP integration tool. Create a new project, and then run the tickle script. Now you will see IDesIP in IP catalog of Vivado. For using this IDesIP in any other Vivado project, you will have to set the repository path of IDS project into the current project. By doing this, you will get the IDesIP in current Vivado project IP catalog. Next step is to create an SoC design in Vivado using IDS AXI client IP. Now add Zync processor IP and then IDS AXI client IP in the design. After that, run auto connection. It will automatically add the AXI interconnect and processor system. Reset blocks. Now select the pin on the IDS AXI client IP and make external connections such that the bits from the first register are connected to external pins. The place and route engine inside Vivado needs to be told that the first register needs to be connected to the LED pins on the Zedboard. A constraint for mapping each individual bit on the IDesIP port to a specific pin on the Zync device is required. Now create the HDL wrapper of the design. Then run implementation on the design so that synthesis, place, and route are carried out. Generate bitstream using the Generate Bitstream option, and then import the bitstream file into Xilinx SDK. Launch the SDK tool. Now create a new application project. Create a sample read-write sequence in ISequenceSpec. Generate the firmware sequences from ISequenceSpec and also the C header file from IDS used for running the sequences on Zedboard. Add the output files generated from ISS and IDS into the source directory in the application project. Use the functions in the main C code in the created application project. Now program the FPGA. Final step is to launch the program on the FPGA using the system debugger. Finally, see the LED follow your sequence on the Zedboard. We have shown how easy it is to specify the hardware-software interface and generate code that works flawlessly. Working with Vivado along with IDesignSpec and ISequenceSpec saves your time and improves quality. thereby reducing costs. This quick turnaround from specification to realization is what Agnisys is all about. Thank you for watching.